So it's my great pleasure to welcome Emily. Dr. Emily Qureshi-Hurst is a stipendiary lecturer in philosophy at Pembroke College, at the Oriel College, and a junior research fellow at Pembroke College, at the University of Oxford. And she worked on a DPhil on the philosophy of time and the Christian doctrine of salvation, which she obtained in 2021. Alongside her academic research, Emily is also a highly sought-after public speaker. She's recently attended a radio free thinking program to discuss religion and science with Nick Spencer and Philip Paul. So we're incredibly privileged to have you with us today. She'll be speaking to us on the topic of the many worries of many worlds, exploring some implications of Everettian quantum mechanics.
So thank you so much for having me. I'm really, really pleased to be here in beautiful Cambridge and at the Faraday Institute as well. So thank you very much, and thank you all for coming, both those in person and online. So I'm here today to talk about my current research project, and in particular, a particular paper that's been published from that research project. The project itself is called Quantum Theology Beyond Copenhagen, and it's run by Mark Harris at Edinburgh. That's the kind of broad project that this paper is a part of. And then my own JRF research has kind of followed from this initial paper that I wrote. So the aim of the Edinburgh-based project was to extend the scope of science and religion's engagement with quantum mechanics. Until now, we as a field have been overly focused on Copenhagen interpretations of quantum mechanics. And this project argues that it's about time we expand our horizons and take a look at some other interpretations. So the Quantum Theology Beyond Copenhagen project sought to do exactly that, and my JRF project is being carried out with this kind of ethos in mind. So my aim in the first paper from this project, and the one I'm speaking about today, is to take a particular physical theory, in this case, the many worlds interpretation of quantum mechanics, and explore some of its metaphysical and theological implications. So yeah, I'm currently undertaking a larger project exploring further worries for many worlds, including issues that relate to moral responsibility and the soul. But today, I'm just here to talk about my first research output, which is the paper entitled The Many Worries of Many Worlds, as you can see up there, which came out in the journal Zygon a couple of months ago. So yes, my aim isn't to argue for any particular interpretation of quantum mechanics. As a science and religion scholar and a philosopher, that's not really my job. So instead, I want to take many worlds as a starting point and explore what it might mean for the theistic worldview if it turns out to be right. And as you will probably have guessed from my title, I'll be arguing that many worlds raises some significant worries for Christian theism, which require our attention. So there are, in my opinion, many worries for theism that stem from many worlds, but the ones that I'll be exploring today are on the slide, and that's personal identity, the problem of evil, and the doctrine of salvation. Now, if you want to read about the arguments in detail, the paper is referenced there, and yeah, I go into it all there. So I want to begin by saying a really brief word about how quantum mechanics is typically featured in science and religion discourse. As I already said, science and religion has been dominated by the Copenhagen interpretation when it comes to talking about quantum mechanics. But in philosophical circles, the reputation of the Copenhagen approach is dwindling and dwindling fast. So Tim Maudlin, philosopher of physics, argues that the Copenhagen interpretation is not actually a physical theory at all, because it doesn't contain either a clearly defined ontology or an unambiguously formulated dynamical description of how that ontology evolves. Instead, it just tells physicists to shut up and calculate, don't ask any more questions. So Maudlin dismisses the Copenhagen approach as a vague recipe whose reputation in the fields of philosophy of physics and quantum foundations is dwindling. And others are in agreement with him. So I think here in science and religion, this encourages us to expand our horizons a little and focus our attention on other interpretations, even if this is a kind of speculative endeavor. The Everett interpretation, in my view, is a perfect candidate because its implications have the potential to radically reconceptualize both our understanding of reality and our understanding of our place within that reality. So, what is Everettian quantum mechanics? Well, what we now call the many worlds interpretation was first introduced by Hugh Everett III in his PhD dissertation written at Princeton in the 1950s. And this is the only thing he ever wrote on it. He wrote his PhD dissertation and then made the perhaps wise decision to leave academia and earn more money elsewhere. So we only have the dissertation to go on. And therefore, there is quite a bit of debate about what he really meant by the theory. And he didn't use the terminology many worlds himself. So the quote I have on the slide is from David Wallace, who's a current and quite passionate proponent of many worlds. So he says, Everettian quantum mechanics really is both a many worlds and a many minds theory, in the sense that it entails that there are a great many versions of myself, living in surroundings much like my own, and interacting with other versions of yourself elsewhere in physical reality. The other worlds and their inhabitants are not abstracta or fictions or mere unrealized possibilities. If Everettian quantum mechanics is true, they're as real as I and you and our mutual surroundings. But what does this really mean metaphysically? To answer that, we need to understand exactly how many worlds came about. So Everett's theory in a nutshell is this. There is a wave function of the universe, and this wave function obeys the Schrödinger equation. At a measurement event, and perhaps in all instances of decoherence, each outcome in the possible range of outcomes obtains. They obtain, however, in different parts of the wave function that cease to interact with each other. As Everett explains in this quote, from the viewpoint of the theory, all elements of a superposition, i.e. all branches, are actual, none any more real than the rest. The total lack of effect of one branch on another also implies that no observer will ever be aware of any splitting process. So the worlds posited by Everettian quantum mechanics are as real as our world. And what this means is their inhabitants are just as real as us. In fact, the worlds contain people much like us. So Wallace identifies two parts in the many worlds interpretation. First, it claims that the universe can be veridically represented by a unitary evolving quantum state. And second, it claims that a realist interpretation leads to a multiplicity of approximately classical, approximately non-interacting regions which look very much like our classical world. So while on first glance it seems really radical and very science fiction-y, that was definitely my reaction when I first came across it, proponents of Everettian quantum mechanics actually say that it's the simplest interpretation available. Far from multiplying entities unnecessarily, many worlds takes the quantum equations as mapping the actual state of the world without adding any further postulates, any hidden variables, or any collapse mechanisms. So in this way, we might say that it's the most mathematically simple interpretation available. And of course, we could have a whole different conversation about which types of simplicity should be preferred in our theories. But this is one of the arguments frequently referred to by the Everettians. So I don't have time to go over all the disputes about the hermeneutics of the theory today. And actually, it's probably not that relevant to what I want to say. But I will give a brief snapshot of two of the different ways that we can interpret many worlds, for those who are interested in the kind of finer structure of the theory's metaphysics. Essentially, there are two versions of the many worlds interpretation, and you can kind of split it along these lines. So the first is the radical version, and this version says that at a quantum event, the universe splits or branches, leading to two or more worlds in which each possible outcome of the given event attains. And this branching is understood as fundamental, i.e. it takes place at the most basic and irreducible levels of reality. So this is perhaps the original reading of Everett, and it's held notably, but not exclusively, by figures such as David Deutsch and Bryce DeWitt. The conservative view, on the other hand, is defended in recent years by David Wallace and Simon Saunders. It might be the more popular one today, and it claims that whilst worlds can be understood as branching, this branching isn't actually fundamental. So instead, it's emergent. So rather than the worlds are patterns in one universal quantum state that emerge as a result of its component parts becoming entangled with each other. Now, critical to understanding this view is the notion of decoherence. So decoherence is a dynamical process involving two systems, which can approximately be referred to as an object and its environment, that come to evolve distinctly from one another. Following decoherence, component parts of the wave function will enter states representable as a sum of non-interacting terms on a particular basis. And because of decoherence, interference between various wave function branches is impossible. Therefore, the systems then appear to behave classically from within the perspective of individual branches, and this is the reason we have a first-person experience of a singular world. And of course, Everettians acknowledge this. So in other words, When a system interacts with its environment, leading to decoherence, quasi-classical branches emerge from the quantum microphysics. The view is called the conservative view because it's not committed to the more radical claim that splitting is a fundamental physical process. So we do still get many worlds on this view, but they aren't fundamental. So we can kind of explore a bit more the differences between these views using the famous example of Schrödinger's cat, or in this case, Emily's cat, whose name is Raymond. So I'm sure you're all familiar with it, but I'll just go over it in case anyone isn't. And because we're using photos of my cat, and I do quite like him, we're going to say the options are asleep and awake, rather than alive and dead. So this version of the problem is as follows. Imagine that Raymond is locked in a box with a device that will break open a vial of sleeping gas if a radioactive particle decays. The likelihood of decay during the hour the experiment is set is 50-50. So before the measurement takes place, textbook quantum mechanics dictates that the particle is in a superposed state of both decayed and not decayed. But these are incompatible states. So how can one cat Raymond be both asleep and awake? The paradoxical conclusion was intended to show how weird quantum effects are when they're translated to the macro level of human experience. We just don't see cats, or anything really, behaving in the way that quantum objects do. So Schrödinger's cat is intended to unearth a problem. Now, the radical version of many worlds solves this problem by claiming that the case doesn't involve a superposed cat or a cat in two incompatible states. Instead, it involves multiple worlds, some of which contain awake Raymonds and some of which contain asleep Raymonds. In short, each possible outcome of a given event, i.e. decayed, not decayed, asleep, awake, actually happens. But they happen in non-interacting branches of the wave function that have split off from each other. So basically, whatever state of affairs we observe only tells us where we are. It doesn't tell us anything more than that. The other worlds and the other options, the other outcomes are all equally real. Now, the conservative version solves the problem of Schrödinger's cat by claiming that Schrödinger's cat becomes entangled with the box with the surrounding room, the room with the house, etc. And this leads to the emergence of two boxes, two rooms, two planets, and ultimately two worlds. So though these worlds are supervenient on the same microphysics and share identical histories, because of decoherence, they go on to evolve independently. And because of the special way our universe evolves, it's not misleading to say that there are many worlds, even if those worlds emerge from the complex behavior of the fundamental quantum state and are not themselves fundamental. So in a sense, this kind of metaphysical dispute isn't as relevant to what I'll be talking about today, but I'm going to proceed as though the radical version is true, because I think there are, if we take the more extreme version of the theory and see if theism works there, then theism's kind of going to be okay in the more conservative reading of what many worlds might mean. So, if this radical reading of many worlds is true, then there are many interesting implications to investigate. For example, there are countless persons who share our past experiences, who have branched off from us and will go on to live different futures. Who are these people? Are they really versions of me? And should I care about what happens to them? So this leads to the first worry that I want to talk about for many worlds, and it relates to personal identity. Now, almost all of us have the deep-seated intuition that we continue existing throughout the various epochs of our lives. Though we might colloquially say, oh, I was a different person back then, or I'm going to be a new woman moving forward. We don't really mean to say, in any serious, substantial, or metaphysically meaningful sense, that the person we were in the past, or will be in the future, is a qualitatively different human being than the person we are now. You might be wondering why I'm starting a science and religion talk by talking about personal identity, and why it might be a worry for theism. And in my view, the answer to that is quite simple. Theism, specifically Christianity, doesn't make sense if individuals can't have personal relationships with their God that are developed continuously over the course of a lifetime. The entire notion of relationship requires an ongoing, reciprocal interaction that's capable of growth and development. I need to carry on existing as the exact same person if we're to make sense of the idea that I can have a meaningful relationship with God that persists as I persist through time. Theism also requires individuals to be justly held responsible for their actions, both in this life and perhaps in the next. So this is integral to both moral responsibility and soteriological, eschatological responsibility as well. if I can't continue to exist through time, I can neither enter into an ongoing relationship with God, nor be held responsible for any past actions, as those past actions weren't committed by me. They weren't committed by the same person that I am now. So, our continued existence and our profound connection with a single and unique sense of selfhood is a deeply held and personally very valuable intuition. Because philosophers love causing problems for even our most deeply held beliefs, personal identity has received a lot of philosophical attention over the last 2,000 years, and there's really useful resources there that I can draw upon when I'm looking at this issue in the context of many worlds. So there are several proposals for what constitutes one's continued existence through time, and in typically wordy fashion for philosophers, they call these the persistence conditions of transtemporal identity. Just rolls off the tongue. And although there are lots of candidate explanations for what could constitute our continued existence, they can generally be categorized into A, psychological continuity views, and B, bodily continuity views. On the psychological continuity view, a baby and an old man, for example, are numerically identical, meaning they are the same exact person, if and only if they are indirectly or directly psychologically continuous with each other. So this might mean the old man remembering being the child, or it could mean him remembering some previous stages of his life, and these stages being linked to prior stages by chains of memories, even though the old man can't remember being the baby. It could also be something as simple as the old man and the baby being connected by streams of first-person conscious experience. So the old man can still be the same person as the baby, even if the man doesn't remember being the baby, as of course none of us really do. On the physical or bodily or animalism view, however, the baby and the old man are the same person if and only if they have bodily continuity. And what that means is basically that the body that was once a baby has grown and developed into the body of the old man. Even if there are no exact cells from the baby's body and the old man's body, and I think it's between 5 and 7 years we undergo complete cellular regeneration, but there's, well, we don't need to get into the kind of metaphysics of that, but the idea is that it's the same body that has developed from the baby into the old man. In other words, they're different developmental stages of the same human animal, hence why animalism is sometimes talked about in conjunction with the bodily continuity view. So there are others, but I think these seem to be the primary contenders, at least in the philosophical literature on this. So these will be the ones that I will be considering today. So one way that philosophers like to explore various persistence conditions is through thought experiments. Thought experiments are really useful tools that allow us to consider various situations in which identity might be lost or preserved. You know, we kind of basically stress test it in different situations and see what works. So a relevant thought experiment that I'll be talking about quite a lot today is known as fission cases. So fission cases were originally inspired by cell fission, a process whereby a cell splits into 2 or more identical copies of itself. Now, these thought experiments are intended to examine whether personal identity can be preserved in such a scenario, if it were possible for human beings to undergo fission. Discourse on fission cases typically begins by imagining an individual splitting into 2 persons who at least seem to be exact copies, both physically and psychologically, of the pre-fission individual. So more formally, we can set up the problem in the following way. Let's call Alice a being who will undergo some fission at some future time, and let's call the 2 persons who will exist post-fission lefty or righty, as we don't want to commit ourselves to saying that they are or aren't Alice at this present time. So the question is, after fission, is Alice identical to lefty, righty, both, or neither? To help us begin to answer this, we can look to various philosophical principles. And one of them is known as Leibniz's law, and it's really useful here, actually. So according to Leibniz's law, if 2 objects are numerically identical, then they must have exactly the same properties. And moreover, identity is a transitive relation, meaning that if Alice is identical with lefty, and lefty is identical with righty, then Alice must be identical, then lefty must be identical with righty. So in this case, it's clear that lefty and righty are not identical with each other. They have a multiplicity of different properties. They have different streams of first-person experience. They occupy different locations in space. They can move independently of each other if they wanted to. They could part ways and never meet again. So they clearly don't share all the same properties. And so lefty and righty are different persons. But on this basis, Alice can be identical to neither of them. Derek Parfit echoes this sentiment, writing that identity is a one-one relation that holds between individuals and themselves. And so it collapses into incoherence when branching occurs. So if we hold fast to Leibniz's law, then fission must be death. This conclusion is unproblematic for most bodily continuity theorists, particularly if Alice's original body is gone. It might get a bit more complicated if the body is a kind of exact copy, but strictly speaking, if the body is gone, then that constitutes the end of the person's existence. But the psychological continuity theorist faces much bigger problems. They must conclude that both lefty and righty are numerically identical with Alice, because each shares psychological continuity with Alice in exactly the same way. But lefty and righty are not identical with each other. So this violates Leibniz's law and causes quite a big problem for the psychological continuity theorist. For this reason, philosophers have sought various solutions, and I want to talk about a couple of them today. Now, before doing that, it's worth saying that without many worlds, fission cases have been regarded as interesting, but currently unrealizable, maybe never realizable philosophical exercises, sort of brain teasers really, with limited real-world application. But if Everettian quantum mechanics turns out to be true, then fission has been part of reality since long before philosophers existed to contemplate it. So what are we to make of personal identity in a world in which each of us could be doomed to split into almost an infinite number of future selves? How can we solve this problem of personal identity in many worlds? So there are a few solutions available, which I have drawn from the philosophical literature on personal identity. And the first is the multiple occupancy view. So in brief, the multiple occupancy view claims that if there is fission in your future, then there are multiple occupants of your body up until the point that fission occurs. So in the case that we're talking about here, before Alice undergoes fission, she actually contains both lefty and righty within her, as you can see, and then they split out into separate persons. So Derek Parfit, who's written lots of stuff on this, argues that the multiple occupancy view greatly distorts the concept of a person, and for this reason it should be rejected. And I think I'm in agreement with Parfit on this. Not only does the multiple occupancy view profoundly violate our intuitions about, even when the context of bifurcation about what it means to be a person, it collapses into complete absurdity in the context of Everettian quantum mechanics due to the scales that are involved here. So physicist Sean Carroll has a useful quotation I'll read out now about the sheer scales involved in this. So he says, quote, "We don't know how often branching happens, or even whether that's a sensible question to ask. But we do know that there's a lot of branching going on. It happens every time a quantum system in a superposition becomes entangled with the environment. In a typical human body, about 5,000 atoms undergo radioactive decay every second. So if decay branches the wave function in two, that's 2 to the power 5,000 new branches every second," end quote. And actually, this is only a fraction of it. The quantum events that occur within us are not limited to radioactive decay. Indeed, branching may well be occurring as many as an infinite number of times per second. So if branching occurs as frequently as this, then according to the multiple occupancy view, I contain a non-denumerable infinity of persons at any given time. This is metaphysically curious, to say the least, and definitely doesn't square with our first-person experience of ourselves as a unique and enduring subject. So this leads to a second problem, that not only would we contain incomprehensible multitudes, but we also don't even know who we are at any given time. So a very legitimate question is raised by this view: which of the multiple occupants is me, if only one can be? And actually, there's no good answer to this question, in my opinion. So philosopher Paul Tappenden agrees, writing, quote, "An utterance of I in the context of multiple utterance cannot straightforwardly be assumed to refer to the utterer. The semantic rule, the word I refers to the speaker in any sentence in which it occurs, cannot be adopted without further ado," end quote. There's no reliable way to say that individuals can, with certainty, refer to themselves and not some other occupant of their body that will later branch off from them. So on the multiple occupancy view, the word I cannot have self-referential certainty. And in my opinion, this is a big problem for the view. So I think it's fair to say the multiple occupancy view is far from compelling. claiming that at each moment of our lives, we contain perhaps an infinite number of overlapping persons who share our thoughts and experiences and can't be distinguished from those thoughts and experiences, stretches our reasonable, common sense understanding of identity beyond breaking point. At least for the theist, our intuitive understanding of personal identity as a one-one relation between individuals and themselves, and not a one-many relation between an apparent individual and a non-denumerable infinity of persons, stages, or multiple occupants, must be in some sense meaningful. We shouldn't need to abandon the idea that I is a word by which we can with certainty refer to ourselves, unless we're provided with really strong, perhaps overwhelming evidence in favour of doing so. But such evidence is not available at present, so I think we should abandon the multiple occupancy view, or at least view it with extreme scepticism. I don't think it can solve this worry for many worlds for us. So there is an alternative which avoids these problems, which is great, but rather more unhappily, it implies that each time branching occurs, Alice dies. We all cease to exist. So this view is called the no branching view, and it basically is grounded on the idea that identity is an equivalence relation, which means it's reflexive, symmetrical, and transitive. So it can only be a relation, a one-one relation between something and itself. This is an idea we've touched upon already. So for this reason, it includes a no branching criterion or condition into the psychological continuity view. In doing so, it manages to avoid the problems of overpopulation and self-referential uncertainty by ruling out the possibility that multiple people can be identical with past persons and each other. So the no branching view holds that Alice's continued existence depends on any future person's psychological continuity with her, but it adds the caveat that no other being can be psychologically continuous with her. Therefore, the no branching view claims that before fission, Alice exists, and after fission, Alice has ceased to exist. But there's a weird consequence to this view, and that is that if just Righty had come into existence, sharing psychological continuity with Alice in the same way we've been talking about before, then the no-branching psychological continuity theorist would say, rightly, that Righty is identical with Alice and Alice has continued to exist. That kind of fits with our intuitions. So one person sharing Alice's mind is Alice. But when there are two persons, perhaps, well, arguably meaning there's more of Alice to go around, we're forced to conclude that instead of surviving, instead of increasing her, I don't know, in case of being even better for her, it means actually that she's died. So once Lefty is introduced and branching takes place, Alice has ceased to exist. And this kind of feels quite weird, I think. Instead, the new persons aren't Alice. They've stepped fresh into existence as Alice was destroyed by the splitting of worlds. So this also feels totally alien to our intuitive understanding of our own identity, I think. And it leads to the conclusion, if many worlds is true, then the 5-6-year-old child that I remember being is A, not me, and B, is dead. And that just doesn't sound right, doesn't feel right. So on this view, I'm not even the same philosopher who started giving the talk, despite the fact that I remember coming into the room, beginning to speak, and I've had the continuous phenomenological experience of speaking since that moment. If many worlds is true, and we want to retain some semblance of the concept of the continuance of personal identity, then we probably should reject the no branching criterion as well. So there's a third option I want to talk about, and that is stage theory. So this is presented by Paul Tappenden, who works on the many worlds interpretation. And he says specifically in an Everettian context, we ought to adopt this stage view of personal identity, which was initially developed by Theodore Sider. And it claims that persons are actually stages. So at each moment of your life, you are at most a single person stage, but that a person stage is sufficient to count as a whole and complete person. So future branches contain future counterparts to Alice, who share Alice's history, but these new person stages are individuals in their own right. In effect, branching constitutes the birth of new persons without the old persons having died. In a way, we can think of this view as being somewhat similar to produrantism, whereby persons are comprised of temporal parts, and thus are never wholly present at any moment of their lives. But it differs in the more radical claim that persons are not comprised of stages, they are stages. So although detailed consideration of this view kind of falls outside the scope of this talk, I encourage those who are interested to read Tappenden's work for further discussion on this. I think there might be promise in this view, but I think more work needs to be done to adequately establish how persons who are stages nonetheless can have ongoing relationships and kind of continue to exist in a non-piecemeal way. So there we have it. That's the first worry for many worlds, and that's that it cannot make sense, easily at least, of personal identity. So I've looked at a couple of solutions, but none of them seem, to me at least, to straightforwardly recover our ordinary notion of personal identity in an Everettian context. As the continued existence from birth to death is necessary for many of the core claims of theism to work, this is quite a significant problem. Okay, let's move to worry number 2. In whatever way one answers the identity question, it is the case that on many worlds, the many individuals with whom we share a past, but not a future, i.e. the many versions of us, maybe, exist. Presumably when worlds diverge and evolve through time, both the worlds and their inhabitants end up looking rather different to the worlds they split from in the distant past. So if this is the case, then there will be many versions of me, many Emilys, each living out the various possible iterations of my life. And if that's the case, then it must be the case that there is at least one Emily living the worst possible life that it's physically possible for me to live. And there will be many, many Emilys living very bad lives as well. So I want to argue that this should matter to an all-loving God, all-loving creator God, importantly, if such a being exists. Now this worry, as you can see there, pertains to the age-old problem of evil, i.e. the problem posed by evil and suffering to the existence of a creator God who knows, sees, and can prevent evil, but manifestly allows it, at least in some instances. This problem is the most old and frequently cited argument against the existence of God, so I'm sure you're all familiar with it anyway, but in extremely broad brushstrokes, it holds that evil and suffering presents a significant challenge to the existence of the God of classical theism, because it seems to be incompatible with the properties of omniscience, omnipotence, and perfect goodness. If God is omniscient, i.e. all-knowing, then God is aware of all instances of evil. If God is omnipotent, i.e. all-powerful, then God could stop all instances of evil. And if God is all-loving, then God should want to stop all instances of evil. And yet, a cursory glance around the world shows us that evil exists, or at least suffering exists. So some further explanation is required to make sense of this. Evil and the suffering it causes tends to be delineated into natural evil that occurs as a result of natural processes like earthquakes and evolution, and moral evil that occurs as a direct result of human agency, i.e. murder. The argument from evil comes in various different forms, and it's most commonly divided in accordance with whether the argument is inductive or deductive. In the latter case, if the premises are true, then the conclusion must be true. And in the former case, the truth of the premises increases the likelihood or increases the evidential basis of the conclusion. And they tend to be referred to as the evidential and the logical problems of evil, respectively. My concern today will be the evidential problem of evil, as I'm using the amount and the distribution of evil in the world as evidence against the existence of a loving God in the context of many worlds. And I will argue that many worlds raises both a new and an enlarged version of this problem. So the evidential argument from evil, or the evidential problem of evil, is inductive in form, as I've already said, meaning that the premises support but do not entail the truth of the conclusion. The evidential argument cites various different sources in support of the basic idea that evil and suffering that we see around us provides very compelling existence to reject the existence of the God of classical theism. And on balance, according to the argument, the evidence supports the atheist or the anti-theist position. So the evidential argument uses some or all of the following: particular instances of evil and suffering, or particular distributions of evil and suffering, or the sheer amount of evil and suffering. These kind of all play into it in slightly different ways. As I've already mentioned, I'm going to argue that many worlds presents both a new and an enlarged version of the problem of evil. I'm going to start with the enlarged version, which involves claims about a significantly larger amount of evil in an Everettian multiverse. And the new version is that God chose laws of physics that seem to entail certain types of suffering that seem contingent on the other universe models, but necessary on many worlds. So yes, let's start with the enlarged version. This is best explored in dialogue with Marilyn McCord Adams and Stuart Sutherland. They define a particular set of evils, which they call horrendous evils, and I've got the definition up on the slide there. So they say, Evils, the participation in, meaning the doing or suffering of which, gives one reason prima facie to doubt whether one's life could, given their inclusion in it, be a great good to one on the whole. And such reasonable doubt arises because it is so difficult humanly to conceive of how such evils could be overcome. Adams and Sutherland argue that standard responses, i.e. your well-known theodicies, fail in the light of such horrendous evils because they tend to be both generic and global solutions to deeply individual problems. Broad claims about free will or soul-making are not going to soothe those who are lost in the midst of acute suffering. Adams and Sutherland elaborate, arguing that the reason for the failure of these standard responses is that they do not distinguish between two equally important descriptions of God. On the one hand, God is described or understood as a provider of global goods. But on the other hand, God is understood as a loving parent who cares deeply about each individual person. The problem is, generic global solutions paint only a picture of God as a provider of global goods. These global solutions don't work for individual problems always, because individuals need a solution grounded in a latter description of God as a loving parent who cares about them and their problems individually and intimately. This comes to a head when considering the way in which Many Worlds specifically enlarges the problem of evil. So I think it's pretty fair to say that the Everettian multiverse contains far, far more suffering than an ordinary universe, on account of there being countless versions of us, some of whom are living the worst possible life that we can live. Now, you may have had this thought, you might be an optimist. The optimist could turn this on its head and say, okay, there's a lot more suffering on Many Worlds, but there's a correspondingly greater amount of good as well. For every suffering version of me, there's at least one version living the best possible life that I can live, and countless more living very, very good ones. So on balance, the distribution of good to evil isn't actually that different from the world that we see around us, the kind of quasi-classical world that we are living in. And therefore, the problem of evil, maybe it's not actually that much worse post-Everett than it was before. So I can see the appeal of this on the face of it, but I think such a response fails because, well, for exactly the same reasons that Adams and Sutherland provide. God is not only a provider of global goods, caring about the distribution of good and evil across all the branches of the universal wave function. God is supposed to be a parent who loves each individual person. As a provider of global goods, sure, we could see how God might choose a design that vastly increases the number of persons who enjoy virtuous, joyful, or fulfilling lives. But as a parent who loves each individual creature, it seems inconceivable that God would create a reality in which there is at least one version of every single person living the worst iteration of their life possible. Any argument regarding the global distribution of goods and evils flat out ignores the plight of those individual persons who are suffering most greatly, recognizing only one aspect of the divine nature. The suffering of each of these persons should be something to care about and something to avoid, not the necessary price to be paid for the happiness or goodness afforded to other versions elsewhere. Joy and suffering are not morally equal. So if you're forced to choose between curtailing the joy, pleasure, and happiness of one person to stop another person's suffering, our moral intuitions tell us we really should stop suffering. That should take precedence. So the benefits that befall some versions of me are vastly outweighed, in my view, by the price that other versions of me have to pay. So I do think it's fair to say that Many Worlds significantly enlarges the problem of evil. However, it is the case that our observable world already contains an inordinate amount of suffering. So you might still claim that while the problem of evil might be a bit bigger on Many Worlds, we already have a pretty big problem to contend with anyway. So maybe Everettianism does little to reshape the contours of this ancient and persistent debate. For this reason, I also want to argue that Many Worlds presents the problem of evil in a new way. From the very structure of the Everettian multiverse, suffering follows necessarily. It's no longer a contingent matter whether or not one's future will contain horrendous evils, extreme suffering, or profound loss. Somewhere in the Everettian multiverse, there will be versions of you experiencing all these things. Classical theodicies that place the blame for evil with humanity or with original sin, with the fall, can't work here because your suffering is woven into the very fabric of the cosmos. This is the new problem of evil. If God exists, then God chose to instantiate a particularly cruel set of physical laws that make suffering emerge by necessity for a great number of persons. Following the nomenclature of Robert Russell, this line of argument concerns what he calls cosmic theodicies. Now, these are arguments from and responses to evil that concern the laws and the cosmological structure of the universe. Russell argues that those who deny divine responsibility for evils that follow from the physical laws elevate the problem of evil to one of cosmology. But according to Russell, this response fails for those who claim that God is truly omnipotent. Because God, as an omnipotent creator, must have had radically free choice over the fundamentals of nature, including the laws of quantum physics. So a truly omnipotent God could have created another type of universe altogether in which the cruelties of our own universe would have been avoided. So cosmic theodicies don't really solve any problems at all. They just push those problems back one step. We might say God is not directly responsible for the individual instances of suffering, but we might say that God is not directly responsible for the individual instances of suffering, but God is indirectly responsible insofar as God created the features of the universe which cause that suffering to emerge. God can't abdicate responsibility for the suffering of those specific persons who suffer most greatly, because God chose the laws of nature from which that suffering follows. In my view, if any theist contests this, concluding instead that many worlds is the best of all possible worlds following Leibniz, or that the universe contains necessary disvalues that allow the positive characteristics to emerge, i.e. like what Christopher Southgate's doing, then in my view, the burden of proof is on theirs. So we maybe need some sort of Everettian theodicy, like we see evolutionary theodicies being developed in other areas of science and religion. So to sum up this portion of the talk, I've argued that the theist must face both a new and an enlarged version of the problem of evil if Everettian quantum mechanics turns out to be correct. And that concludes our second worry. So we're now at the last part of the talk, which is the part concerning salvation. And here I want to move away from broadly theistic questions to specific Christian doctrine. One of the most important aspects of the Christian doctrine of salvation is that the goal of earthly life is to attain, or at least begin to attain, salvation. But how is that salvation to be attained in a cosmos described by many worlds? I think this is an important question that we need to give some attention to. Christian scripture claims, at least in some places, that the only way to salvation is directly through Jesus Christ. So two problems, I think, are raised by this in the context of the Everettian multiverse. And the first is the problem of presence. That's what I'm calling it. So in a different branch, a slightly different set of events may have led Pontius Pilate to spare Jesus' life. Or the fetus that became Jesus may have succumbed to a genetic disease of the kind Jim Al-Khalili and John J. McFadden claim are influenced by quantum processes. Indeed, some branches will have split off from this one so far back in the past that their world will be completely unrecognizable to us. In some of these branches, human history will have taken a completely different path, leading to people with no understanding of the Christian God whatsoever. Whether or not one believes this is theologically possible, and that's definitely a conversation we can have, it is physically possible. So the worry then is this: can we confidently claim that Christ exists in all branches? Christological presence is of utmost importance. Why? Well, we can answer this by referring to the work of 20th century theologian Thomas Torrance, who wrote on the relation of physical space to the incarnation. Torrance argued that space and time are created forms of rationality that exist in distinction from, but are importantly related to, the rationality of God. In fact, Torrance goes as far as to say that now the incarnation has occurred, all other conceivable routes to God within space and time have been invalidated. This act formed the great axis in God's relation to the world of space and time, so he says. Now, if he's right, then the relationship between God and creatures in the spatio-temporal realm, including creatures' ability to receive the Christian message and be saved, is inescapably bound up with shared spatiality. The physical and spiritual presence of Christ in the world of space and time forms this inescapably spatio-temporal context for divine self-revelation. What this means for many worlds is this: if there are persons who exist in branches that do not contain Jesus Christ, and the soteriologically significant events of his life, then they are unable to relate to God in any way. They don't occupy God's spatio-temporal, self-revelatory context. So although we can still say that Christ is in creation, he can't be claimed to be in all non-interacting branches of that creation, and perhaps that's a problem. But, well, it leads to the second problem, actually, that I have identified, which I call the problem of epistemic access. So this is, if the Christian message is epistemically inaccessible to all those who don't share a branch with any version of Christ, then his soteriologically significant message is in principle out of reach for them. And this is a big problem for any theist who claims that the only route to salvation is directly through Jesus Christ and within the shared spatiality of our physical world. So this problem resembles the problem of what to do about people who are born before Christ or who live in a far-off place that the Christian message hasn't reached. And I'll speak a bit more about that in a minute. So the third worry for many worlds relates to both Christ and salvation. Can those in branches without Christ be saved? Well, maybe. So I want to suggest that this problem may be able to be overcome by universalism. So universal salvation, or universalism, is the claim that every created person will eventually be reconciled to God, no matter their, personal shortcomings or their misdeeds in this earthly life. Importantly, in the context of Everettian quantum mechanics, universalism provides us with an explanation for how those who are unable to access Christ for reasons outside of their control are nonetheless able to be saved. Whether or not Christ is present in their branch, there are many means by which the inhabitants of that branch can reach atonement. So yes, we can think of these cases as analogous to those individuals who lived in a time before the Christ event, or who lived in a region of the world that didn't have access to the Christian message during their lifetime. For them, the Christian message was fundamentally inaccessible, and yet it seems pretty immoral to hold them responsible for this, as we cannot control our birthplace or birth time. It's a matter of lottery, really. And salvation shouldn't be decided on chance alone. So, rather than the Christian having to say these individuals cannot be saved, universalism provides us with a framework in which their salvation follows as an inevitability. So for those in branches that do not contain Christ, salvation is still within reach. And for this reason, I think universalism makes the most sense out of salvation in the context of Everettian quantum mechanics. So there we go. In conclusion, I've argued today that the many worlds interpretation of quantum mechanics is worth taking seriously. And when we do take it seriously, worries arise for theism that relate to personal identity, the problem of evil, and the doctrine of salvation. I think there's more worries as well, but obviously these are the ones that I wanted to cover first. Now, I don't want to say that these problems are insurmountable. I think that there's probably lots of stuff we can come up with to kind of start tackling these problems, but I do think we need to start tackling them. So fresh responses are required in order for us to solve these worries for many worlds. And then if many worlds turns out to be correct, theism is on firmer footing. So thank you very much.
Thank you very much, Emily, for this wonderfully rich and complex seminar. So I can see some questions coming through. Please online continue to send through questions, but hand on Rodney. You want to get us started?
Thank you very much indeed. Just on your last point, there's a similarity here between other planets.
Yes.
Now, John Polkinghorne made the point, though, that we've been privileged to have God reveal himself to us on this particular planet. And that would seem very unique. In the case of multiverses, then are we incredibly lucky that in our particular branch God has revealed himself to us, even if it's independent of our salvation? So that's wonderful. And then another question is, why not go the whole hog like Leland Harper and say, well, if you know his book, he goes from deism, because everything happens that can happen,
Yeah.
So.
Yeah, I mean, that's definitely one solution. I think the difference between many worlds and other planets, there's definitely similarities we can draw, but there's certain features of Christianity that say there's something special and unique about humans. So that may not apply for other planets. There might be God might reveal God's self in a different way on those planets, but specifically in the context of humans, it's hard to make sense of the idea that there are some humans that wouldn't have any access to the Christian message at all, at least within the framework that's been established within Christian scripture. So yes, there's definitely important comparisons to draw there, but I think there are important differences as well. Mm-hmm.
Thank you.
Hello, thank you very much. I'm an experimental particle physicist, and I've written on quantum mechanics, so I'm fairly familiar with the area. First thing I want to say is that the people I work with don't seem to take very much notice of the many worlds interpretation. It's popular with cosmologists, but not with hands-on particle physicists. But I would also say there are a lot of issues with the actual physical theory, which I can't go through right now, but I'm happy to talk to you about afterwards. So that's my comment for this.
Okay, thank you. Yeah, I do think there does seem to be a disconnect between how quantum physics is used and then philosophical reflection on what it actually means. So yeah, I mean, it's not very useful to think about the many worlds interpretation when you're doing experiments on particles. Even if it is true, it's not really that useful to think about, I think, because you're focusing on the outcome of a particular experiment in front of you. But I still think it's important to think about these, to reflect on these things philosophically as well. And maybe there needs to be more of a conversation between these two camps.
There's a question.
Oh, yes.
Thanks very much for your talk. Mind stretching. So I work with teachers and students in schools, trying to get them to consider science and religion as a sort of thing. So how could students and teachers indeed in those situations, sort of what would be the pathway to ending up doing what you're doing? It seems a sort of quite a long way from my day-to-day.
Yeah, that's a really, really good question. And I think it really depends on the individual. So I can't give you a straightforward answer. But I think historically, people working in science and religion were pretty much exclusively physicists who then had an interest in Christian theology, started doing physics-engaged theology or theology-engaged physics. No, physics-engaged theology. And science and religion kind of came out of that. But people today are coming at it from a variety of different perspectives. So you don't have to be a trained scientist anymore, as I'm not. It does disadvantage you in some ways, but really whenever you're doing science and religion, you are an expat almost, or you're a kind of, you're a newcomer to one area and familiar with one area. So there's actually, to answer your question, there's many different routes. I came up through the philosophy route. You can study philosophy and then look at these questions or theology. Or you can try and take an interdisciplinary approach from the beginning, and places like the Faraday Institute and at Oxford, where I am, are really encouraging that interdisciplinary dialogue from much earlier than has historically been the case. You don't have to train fully in one area and then move to the other. You can have a bit more of a kind of from the ground up approach to interdisciplinarity, which I think is great.
Super, thanks.
I really enjoyed this. Thank you so much.
Thank you.
So much more to discuss.
Yeah.
I'd be curious to hear you think out loud on two questions. One is, to what extent this is same and different in kind to the sort of questions that would be raised by like David Lewis's Metaphysics.
Mm-hmm.
All of these sorts of fission cases, temporal parts, phases, all of that could be worked through
Yes.
in a totally classical setting, right? With many concrete worlds. So I'd be just curious to hear you, is this different in kind?
It's the problems that are raised are very, very similar. But I think so David Lewis talks about modal multiverses, right? So anything that's possible, anything that's logically possible exists somewhere in the multiverse. Whereas I think in many worlds, the class of world branches is much more restricted. So there's still loads and loads and loads of them, perhaps an infinite number of them, but they all have to be compatible with the evolution of the Schrödinger equation and the initial conditions and stuff. So lots of similar problems, but the actual structure of the universes or multiverses would look quite different.
I suspect that's what you'd say, which suggests that these are just a subset of the kind of problems that were already there in Lewis.
Mm-hmm.
And maybe that brings us on to the question, the sort of second thing I'd be curious to hear you, if I may. Just think out loud, is just the notion of a physical theory, right? So when you sort of introduce vague recipes I'm sort of like, what's wrong with a vague recipe? So when you kind of make it tight and say, look, a real theory has a proper ontology and the dynamics worked out, you introduce that ontology in terms of a wave function on a configuration space. But then I'm sort of sitting here thinking, well, hold on, where did all these events come from and these moments come from and these selves and these persons? Like, do you see? So I'm wondering if there's a sort of, a working notion of what a real theory is that's doing maybe a little bit too much work here, but.
Maybe. I think a vague recipe, I mean, it really depends what you want to do with it. So a vague recipe is enough to practically do quantum mechanics and make loads of really important progress in physics. But a vague recipe isn't enough for philosophers or for metaphysicians. So I think it can't be the final resting place. So I think this idea of a more robust physical theory has to be the end goal. If we want to do things like metaphysics with it, because we need these more rigid kind of concepts that we're dealing with, I think, yeah.
So we have a couple of questions from the online audience. I would like a quick, brief response to each.
Okay.
Is that okay?
Sure.
So Mark Warner asked, could we see God's spirit as reaching into all possible cosmoi to bring salvation, visually all the different branches?
Yeah, possibly. So maybe through the idea of a deep incarnation where Christ is present absolutely everywhere in everything physical. I don't know huge amounts about it. I've only heard one talk on it. So yes, possibly, if you want a brief answer, yes.
Wonderful. And Peter Jevons, apologies, asked, why is personal identity a concern specifically for theism? Don't atheists care about their personal identity?
Well, I'm an atheist and I can say, yes, I do. But I think it's more, I mean, here I'm talking about the consequences of many worlds for theology or for religion. And so I think it's important there as well. I'm not saying it's not important for atheists, but I think it is specifically important for theism over and above what the atheist has to say about their own identity, I think. I mean, there are some atheists who are perfectly comfortable with the idea that identity is a useful fiction, and actually we're more like, well, I don't know, there's lots of different ways of thinking about it, but that strict numerical identity isn't actually that useful. So Derek Parfit says, all we need to do is survive from 1 minute to the next. We don't need to be exactly the same. But I think theologically, it's really important that personal identity is given a robust foundation. So yes, that would be what I'd say there.
Thank you. Well, there is a, oh no, that's just a follow-up comment. We have 1 minute for one quick, yes, Dennis, one quick, very quick one.
Okay, I'm an old-fashioned biologist, okay, so, and I mean, we biologists, we still think about falsifiability in our theories. I know you're not here to defend Everettian quantum mechanics. On the other hand, I sit there thinking, well, you want us to take it seriously. I only take scientific theory seriously if I can think of some way of falsifying them. Can you think of some way of falsifying it?
So probably not. And that is a big problem for many worlds. If you want to keep it neatly and strictly within the boundaries of a physical theory. But I think whenever we're doing theory interpretation, metaphysics has to come into it to a certain extent. But yes, it would be very difficult, maybe in principle impossible to falsify. And so scientifically, that is definitely a problem. And it's a problem that's seen as more serious by some people than others. But I do think whenever we are doing interpretation of science, we've got to move beyond just falsifiability and think about other metaphysical considerations as well. But when it comes to the actual, I mean, how could we ever test many worlds? I'm not sure. And yeah, that's a problem. So thank you.
That is a wonderful place to stop. I'll continue the discussion on philosophy of science and the way in which philosophy of science plays a role in these debates between physics and theology. So please may you join me in thanking Emily in giving this wonderfully stimulating seminar.